Okay, let's close out this chapter with a couple of thoughts on the two-way interactions, tropical, extratropical, which we implied in the beginning, especially with that figure from Peter Webster's book showing the westerly duct and the tropical upper tropospheric trough in the eastern Pacific Atlantic oceans that bring extratropical signal in, and then the westward propagation of the PV substance, for example, and then northward propagation back. Essentially comes down to moist dynamics in the tropics, because convection appears to be key. And then there are instabilities, so moist static instability in the tropics, which is smoothed out or reduced by the convection, is one. And then of course the jet stream, which coming out of Asia and North America is zonally unstable, so that begins to have filaments and eddies being shed. So you have this loop, and the special issues remain in terms of the location of the ISO timescale heating, which is able to reach further like into the extratropical regions, and also the basic background winds, which provide the scale, the meridional scale of the Rossby waves. So this is one example here. This is looking at meridional distribution of Rossby waves with zonal wave number k equal 5 and meridional wave number 1. I think you can read up if you're not clear what that means. And that's on the left side. And on the right side, in the zonal wind, meridional wind, and geopotential height. So you have zonal wind at n equal 1 in A, zonal wind for n equal 2 in B, and meridional wind for n equal 1 in C, and meridional wind for n equal 2 in D, geopotential for n equal 1 and 2 in E and F. Okay, so nonetheless, the main point is, if you look at the background winds here, easterlies, stationary state, and westerlies, the systematic thing you will see is that if you look at the latitudinal bands and the wave signatures, westerly wind regimes favor a much more latitudinally broad scale or reach of the Rossby waves for all n in the zonal and meridional directions, as well as in the geopotentials that correspond to those. So you can see the amplitude of the geopotential is larger for westerly wind regime, and it obviously reaches out almost to the poles for both n equal 1 and n equal 2. And the latitudinal scales here are broader. So all these things matter for sending the tropical signal to the extratropics through the wave dynamics, and the instability calculations typically are done using certain models which represent these convective processes, the moisture processes, evaporation, wind feedbacks, and so on. And there is a wave vector defined by Takayabu and somebody else, which can be used to look at the wave activity flux overlaid on contours of northern hemisphere 300 hectopascal stream function for the leading theoretical intraseasonal mode with the evap basic state. So that's basically the basic state of MJO phase 3 and 5. In terms of the distribution of heating, the stream function contour interval is 3. The arrow length corresponding to 50 is shown here in each panel. So these are intuitively not so obvious maybe, but they are wave activity flux vectors which show you the relation between, for example, this is 3, 4, 5 phase of the Rossby wave, and you can see the meridional reach of this pattern, and then back into the tropics. You can see the perturbations all the way to these polar latitudes. In this phase you have a similar one, but slightly different structure, especially here in terms of extratropical regions. And then you have this mode here. So you have, I'm not going to explain all the details here because it's kind of a long paper with the model and the way these are computed. These are basically horizontal wave activity flux vectors, but basically give you a sense of the instabilities, moist barotropic baroclinic instabilities that generate these patterns or wave activity flux vectors, which can go from the tropics all the way to the higher latitudes. And as we said before, the location of the heating is always critical for how far you can go. So this is a schematic representation of this tropical northern hemisphere interactions and teleconnections from a review article with lots of authors. Eric Maloney is one of the ones that comes to mind. So it's looking at Rossby wave source here. So you can see the shear shown here, and the boreal winter teleconnections through the let's say you can think of this as the PNA pattern. This is the atmospheric river that we mentioned in terms of pumping moisture on long distances into the western United States, which has quite a good predictability because of these scales, which we looked at in terms of coherence in the monsoon patterns, for example. Boreal summer teleconnections here from the monsoon regions going all the way into the Siberian region. That's the monsoon for the South Asian, East Asian, and what is called West North Pacific Mayu Bayou front here, and so on, and the Australian monsoon down here. We have the MJO activity here, which is able to generate the teleconnections as well. Okay, so this is a kind of a summary of the ideas we discussed. Obviously, models have lots of deficiencies, let's say, biases and so on, as we mentioned before. The correct location of the heat source is required, the correct jet stream and its activities are required, and the processes that link them can only be accurate when all of those processes are correctly represented. There are always some deficiencies, but you still try to figure out what is dynamically consistent within the model. To the extent that, for example, model has a monsoon, it has an MJO-like feature. It may not be as strong, it may not be propagating at the right speed, and so on. But when you project onto RMM, it has its own rendition of the MJOs. Then you can see if the model is able to do these processes with its MJOs and its monsoon, and so on and so forth. So one has to deal with whatever the model is able to do and look for the processes within the model, and not always just compare model to observations, because there is some dynamic inconsistency within the model which may allow you to exploit its prediction skills and predictability within the model. Okay, I don't know what else to say, but you can see that this teleconnection is going all the way from the West Pacific down here into the Indian Ocean region, where the genesis of the MJOs happens. So you can see how the teleconnections goes off deep into the extratropics and comes back into the tropics. So waves always allow you to do these kinds of teleconnections, and if they are represented well in the model and the teleconnections are known, then obviously there is prediction to be exploited, predictability and prediction skills to be achieved, right? So that's the chapter then on tropical, extratropical interactions and teleconnections. It's kind of a brief run through, but the details are there in a large number of papers that are cited in this chapter. It's a really rich reference list provided, so you can follow up if you're interested.